Hi everyone, welcome to our video lesson. This is lesson 9.1, Intro to Exponential Functions. This is the first lesson in our next unit, which is going to be Unit 9, Exponential Functions and Sequences. So go ahead and grab your notebooks, something to write with, and your calculator, and you're going to write along with me to keep track of our concepts. But before I get into actually taking notes, I have a scenario for you to envision, okay? You just got a job. Yay! You just got your dream job. And your boss gives you two different pay scales to choose from. Let's see if you can see this. All right. The first one is you get paid $100 today and an extra $500 each day after. Okay. Scenario number 2 is you get paid 10 cents today, but they're going to double it every day after that. And your boss tells you to choose. Which one would you go for? Option A or option B? To make these options a little bit easier to visualize, I wrote out what each pay scale would look like for your first, supposed to cover that up, first 10 days of work. Okay, here's option A where they were going to pay you $100 and then an extra $500 each day after that. So by day 10, you're making $4,600 in 1 day of work. Pretty cool. In option B, they're going to start with 10 cents, but then they're going to double it to 20 cents and double that to 40 cents and double that to 80 cents and so on and so forth. And by day 10, you're making $51.20. Cool. Do you still agree with the first choice that you made? Would you stick to the option that you voted for? Doesn't look like much is changing here, and unless you're very good at picturing far into the future, you might have went with A. Bigger chunk of money, right away, $500 a day seems like a pretty good amount of change. But what I can tell you is that eventually this pay scale B is going to outnumber A by tens of thousands, if not millions of dollars. And I'll show you and it's not that far in the future, just by day 18. Let's put that there so you can keep track of it. Option A, you're getting $8,600, which if you're not greedy, that's a pretty good amount of money. But by option B on day 18, you're making $13,107.20. Okay, now this is as if there weren't any taxes or federal stuff to pay for, and this was just what you were getting paid flat out. But I mean, if I could get paid $13,000 in 1 day, I'd definitely suck it up for the first 17 days before that. Okay, this is right here is the difference between what you've learned in the past. This is a linear function raising by the same amount every single day, and this, you guessed it, is an exponential function. Okay, the growth between day 5 and day 6 is different than the growth between day 9 and day 10 because I'm not adding or subtracting by a constant number every single time. What I'm doing is I'm looking at the y value right before it and I'm doubling that. So the bigger that this number is, the bigger the jump's going to be to get to the next one. Okay, and you can imagine if we kept this job with a B option pay scale, by the time we've been there for, 25, 40 days, I'm going to be paid millions of dollars, and then they're going to double it the next day. Like, that would be pretty cool. All right, so let's look at exponential functions and what we should be keeping an eye out for. All right, so numerically or algebraically, an exponential function is something in the format of this. F of x equals a times b to the x power. Okay, a and b can be any real numbers in the world as long as a is not 0. Okay, because this is multiplication here, if I was taking anything times a 0, I would just constantly be stuck at 0. So that's not going to help me, and that's not what we're looking for. So this a value, any real number, but it can't equal 0. And it represents our initial value, or our y-intercept, of our function. Use some colors here today. So that would be the amount of money that we started with, or the amount of whatever it is that you're measuring when you start your measurement. The B is how much it's changing by. Okay, so in our money example, we were doubling every single day. So sometimes this is known as a growth factor or a decay factor. We'll get into what those two mean in a second. All right, but more commonly, this is referred to as a common ratio. Probably should have put those on the same line. Okay, so a common ratio means that you are using it to multiply every single y value to get to the next y value. And again, we'll get into that in a little bit. Okay. Last but not least, up here, you'll notice that my variable x is there. That's going to remain x. That's going to be my independent variable. Okay, it's going to be in the exponential position, so it's an exponent. It's going to be up in the top right-hand corner. Right, and this is normally going to measure the amount of time that you're measuring something else against. Okay, so if I see any functions in this sort of format, I'm going to know they're exponential, with the key feature being that my variable is in the exponential spot. So let's write down a couple of examples so that you have them in your notebook. Okay, one great example would be the equation y equals 3 times 5 to the x power. Okay. Another great example, f of x equal to 2 times, let's get funky here, 3/4 to the x power. Yes, your numbers can be fractions, they can be decimals, they're all considered real numbers. And last but not least, how about g of x equal to 1/2 times 2.5 to the x power. All right, all examples of exponential functions in equation format. So how are we going to evaluate these exponential functions? Okay. Let's say I'm dealing with one example, f of x equals 10 times 2 to the x power. Okay, and I ask you guys to find f of 0, f of 1, and f of 8. Why not? Okay, well remember this 0, 1, and 8 have replaced the x in my initial exponential function. So what I'm going to do is I'm going to take my calculator. I'm going to type in my function 10 times 2 to the is going to be this caret button, and I'm going to raise it to whatever x value they filled it in with. So to the 0 power gives me an answer of 10. Okay. 10 times 2 to the first power gives me 20. And 10 times 2 to the 8th power, whoa, 2,560. Okay. I'm going to give you a second example. F of x equals 10 times 1/2 to the x power. And I actually want you guys to evaluate for the same 3 x values using this new function. Pause the video and try it. So you'll notice I took the 10 times and I used 0.5 in my calculator because that's just easier for me to type in. I raised it to the 0 power because that was the first x value, the 1 power, and the 8 power to get my 3 answers. Okay, now what happened here? We had 10 as a common answer for both functions, and that's because 10 was the initial value or y-intercept for both of my equations. Okay, so if I plug in an x value of 0, I'm going to get my y-intercept, and in this case, it's the same number both times, this number out here. That's why that's in common. But then in our first function, as that x value started to get bigger, so did our y values. Okay, that's an example of exponential growth. Okay, that's because you have a b value greater than 1. Okay, what's going to happen is as this number gets bigger and bigger and bigger, these are going to jump higher and higher and higher because my common ratio is a 2, my b value inside the parentheses. Over here, I start at the same number 10, but now my numbers start to get, my y values, my outputs start to get smaller as I plug in bigger x values. That's an example of exponential decay. Okay, and that's because b is somewhere between 0